All right, here we are. We're going to be talking about rules of differentiation, and we're going to do four examples. So first, we're going to start. Find the derivative of y equals x squared minus 4x, and then hence find the gradient of the tangent of the function at the point where x equals 2. Okay, so the first thing I'm going to do is I'm going to rewrite this equation so that we don't have this denominator here. So I'm going to call this y equals x squared minus 4 times x to the negative 1. Okay, so now if I'm going to apply the rules of differentiation, this power comes to the front and decreases by 1. So my derivative, I'm going to call it y prime, is equal to 2x. So that power now comes to the front, and this power has decreased by 1. So if I subtract 1, I'm going to have a power of 1. I don't really need to write that power of 1, but it's okay. Okay, and then this power gets multiplied times the 4. So I've got minus 4 times negative 1. All right, that power gets multiplied by the 4, and then now I've got x, and the power decreases by 1. So negative 1 decreased by 1 is going to give me negative 2. So my derivative function now is equal to 2x plus 4 times x to the negative 2. Okay, now if I want to find out the point where x is equal to 2, then I need to plug in, I'm sorry, we're trying to find the tangent. We're trying to find the gradient, which is the slope, when x is equal to negative 2. So I'm going to use this as my gradient function. And since that's my gradient function, I'm going to plug in 2 wherever I see x. So now I'm going to get, so when x equals 2, we're going to get 2 times 2 plus 4 times 2 to the negative 2 power. So now I'm going to get y prime equals 4 plus this is equal to 1 over 2 squared, right? Which equals 1/4, right? So if I've got 4 times 1/4, then I'm going to have y prime equals 4 plus 1, which equals 5. So, so the tangent has a slope equal to 5. Okay, you might want to hit pause and rewind and play this again if you have a question on this. Okay, let's look at the second question. Okay, the next question is, if y equals this, 3x squared minus 4x, find the derivative and interpret its meaning. Okay, so we're going to use the power rule to find the derivative. So this power is going to get multiplied by the 3. So then we're going to end up with 3 times 2 is going to give me 6, and that power decreases by 1, so that's going to become a 1. And then we're going to end up with just minus 4, because this has a power of 1. And so if that power decreases by 1, we end up with x to the 0, and x to the 0, anything to the 0 power is always equal to 1. So if I've got negative 4 times x to the 0, then we're going to end up with this. You may want to play that again to see if you need something. So the derivative is the gradient function. So this is a function that gives me the slope um, that can be found at any point on the original graph of the curve. And it's also going to give me the instantaneous rate of change, which is the slope of y with respect to x. You might want to hit pause and write this down. Okay. All right, next one. Okay, so at what point on the curve of this function, y equals 2x squared plus 5x minus 3, does the tangent have a slope of 13? Okay, so the first thing I'm going to do is find the derivative. Okay, so with this function, I'm going to get the power decreases by 1 and gets multiplied by the coefficient, so I get 2 times 2, which is going to give me 4x. This power decreases by 1, we end up with plus 5. And the derivative of 3, there's no x there, so it's just going to go away. So here's my derivative function. Okay, so, and they've just said that the gradient is going to be equal to 13. So basically, this is my function that gives me the gradient. So if this function gives me the gradient, I'm going to make it equal to, guess what? 13. Okay. So I end up with 4x plus 5 equals 13. Okay, so now we're going to solve for x. So then we get subtract 5 on both sides. We end up with 4x equals 8. So x equals 2. Okay, so when we have a slope of 13, we know that x is going to be equal to 2. Okay, so when x is equal to 2, we need to plug that back into our original equation to figure out what y will be when x equals 2. So here's the equation, and I'm going to plug in 2 in place for x so that we can figure out what y will be when x equals 2. So if I use my calculator, I end up that y is 15. So basically, the tangent of the slope, the tangent of point is going to be 2 comma 15 when our slope is 13. You might want to hit pause and rewatch this if you want to hear it again. Okay, last question. Okay, the tangent of this function at this point has a slope of 3. Find out what a and b are going to be. Okay, so here we go. We've got this function, right? 2x squared minus ax plus b. Okay, so we know that it's going to have a slope of 3. So let's find the derivative. So the derivative the 2 gets multiplied by the 2, we end up with 4x, and the derivative of this is minus a, and the derivative of this is 0, it goes away. So here's my derivative, 4x minus a, and we know that the gradient has a value of 3, and this is the function that gives me the gradient. So I'm going to say that 4x minus a equals 3, and this is going to be equal to 3 when x equals 2. So now we can find out what a is going to be. So now I'm going to get 4 times 2 minus a equals 3. So 8 minus a equals 3. And we're going to end up with, if I subtract 3 on both sides and add a on both sides, we're going to end up with a equals 5. Okay. Now that I know that a equals 5, when x equals 2, I can go back to my original function. Let's just write this. F of 2 equals 2 times 2 squared minus a, which we know is 5, x, oops, I shouldn't write x, 2 plus b. Okay, and we know that this value here is 7, right? Because this is y. So now I've got 7, let's use a different color. 7 equals 2 squared is 4, 4 times 2 is 8, minus 10 plus b. And our only variable is b. So now we've got 7 equals negative 2 plus b. So we add 2 on both sides, and we end up with b equals 9. And those are values of a and b. And I hope this helps you with your homework, and you may want to hit pause and replay to see these examples again.